So
Okay, I see.
there's a pretty wide array of understanding of these ideas, which is fine. I just want to see where everybody kind of was. So you guys, here's the funny thing. Okay, if I said solve x plus 1 equals 3, x plus 1 equals 3, is that an easy answer to tell me? X plus 1 equals 3. If you solve that, what do you get? X is 2, right? Woohoo! If I said solve x plus y equals 3, can you tell me the answer? First off, is there an answer? Is there only one answer? No. Many more. I know what you're saying. Each answer has 2 parts, correct? Can somebody give me one answer to this?
1 plus 2.
Say again?
1 plus 2.
All right, now make it into an answer. What would an answer to this be? It would be a point, right? So it would be 1 comma 2. I love it. And you're all like, this is what I said. I'm with you. But just to really make it clear, answers to this is points. Give me another one.
2-1.
2-1, holy shit, right? What about 8 negative 5? Does that work?
Mm-hmm.
I mean, how long could we go with this? What about 1.7, 1.3? Yes? Are you guys? I really want you to understand this. If I said, tell me the answers to this, do you want to list them? Do you want to list all the answers? How many answers are there? Infinite frickin' answers. So if somebody's like, tell me the answer to this or you fail, right? We're going to give them a picture. We're going to give them a frickin' picture, right? I really want this to make sense. The most basic reason we graph things is because they are a visual representation of the answers to the equation. If I have x plus 1 equals 3, I don't need a graph. It's got one answer, 2. Get away from me, right? If somebody's like, give me the answer to this, you're like, what the hell, man? So we make some answers. 3, 0, 2, 1, 1, 2. And then this guy, the person's like, oh, that's not all the answers. So we're like, all right, screw you. There we go. 3, 0, 2, 1, 1, 2. There. Now go find whatever you want. Leave me alone. I got stuff to do, right? I really want that to make sense. Because I know on one level, students are like, why the shit do we graph this shit? You know. Hopefully most of you guys are understanding that graphing stuff helps you see what the hell a function's doing. But the most basic reason we graph is it's the quickest way to answer the question, what are the answers, stupid thing, right? You guys understand that? Is that all right? Okay. So, every point that this line goes through, what must it do? Why does the line go through it? What must it do?
Must equal 3.
Must work in that equation, right? So if the line goes through a point, the point must work in that equation. And if a point works in that equation, the line must go through it. On one level, that seems really basic, but on another level, you're not used to saying it like that. So the first series of questions are basically worded like that. Where are they? There they are. Is the ordered pair a solution to the given equation? So how do you check?
Plug it in.
Plug it in. 2 minus 3 times 2 equals 4. 2 minus 6 equals 4. Is that true?
Nope. No.
Is that true?
No.
No. No. So is the point on the line?
No.
No. So whatever the answer is to the first equation, that's the same answer. I mean, the first question, it's the same answer to the second question, right? Now the trick on part B is, what do you put in for A? What do you put in for B? This is kind of like the next level. So I give you an ordered pair. What's the first number normally represent?
X.
X, and the next one is Y, correct? Unless otherwise stated, every ordered pair you're given is in alphabetical order. So that first number, 1, what letter does it go in for?
1.
A, alphabetical order, correct? So what would go in for B?
7.
7 minus 4 times 1, is that 3?
Yes.
Check. So is the order pair a solution? Yes. Does it go, is it on the line? Is 1, 7 on the line that this would make? Yes? My Y got a little excited there. Okay, it's actually a feet. It's actually a Greek letter. It's not going there. You guys semi with me? Is this coming back a little bit? So it's worded strange on purpose. Because that really gets to the heart of why we graph something. The most basic reason why we graph something. Number two, if I give you the reason that this kind of equation sucks is because the number of unknowns is too damn high, right? So if I give you one value, it becomes a normal equation that we're used to, right? So in the first line there, what am I telling you? There's like 4 problems here, right? A, B, C, D. So in part A, what am I telling you?
X is 1.
X is 1, so if I put a 1 in for X, add 1 is 8, divide by 2, I get 4. Is that cool?
Mhm.
4. So part B says to put what where?
Y is 2.
Y is 2, so I get 4 minus X equals 7. I get X is negative 3. I'm going to do this a little quick, because you guys can solve equations. C, I put a negative 5 in for X. So I get 2y plus 5 is 7. So I get y is 1. And for D, I put a negative 5 in. Oops, sorry. A 5 in for y. So I get 10 minus what is 7. So that's 3. Is that cool, everybody? Did I get those right? Oh, good. Okay. How can you tell really quickly as you start to plot these points that you got something wrong? If they don't create a line, because I know this equation has to be a line. There's no squares. It's all first power, so it's got to be a straight line. So if I start plotting points, I'm like, oh, cool. Oh, shit. What the hell? That's probably wrong. You should go recheck that one. Does that make sense? So I always get somebody who's like, and you just start connecting all their points. I'm like, no. You did a mistake. It should be a straight line. Yes? So let's plot these. Thankfully, what can I make my scale? So that's a consideration here, right? Scale is a consideration. What if one of my outputs was 28? I don't want to do 1, 2, 3, 4, 5, 6, 7, 8. No. I might go by 4s then. Does that make sense? 4, 8, 12, 16, or whatever. You have to consider what scale to give yourself. In this case, all the numbers are from 1 to 5. So I can just use a scale of 5. That's nice. All right, everybody, strap in. Jack, what the hell? Yeah, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4. Negative 1. Okay. So 1, 4. Jiminy Jeebus, I can't see that. 1, 4, negative 3, 2. Negative 5, 1. And 3, 5. Do those look like they line up? Yay! Oh my God, it's like the straightest line I've ever made. You were here to witness that. All right. Is that cool? Now again, I just want to say this. You guys come into this class with very different levels of ability, right? And we already talked about the fact that we were forced to get rid of our algebra class. So those of you that wanted to take it, I'm really sorry it's not there. Trust me, the math department wishes it was still there. So some of you guys really would have probably wanted to take that just to kind of beef your stuff up, but you can't do that. Shit. And some of you guys could probably go into calculus. I don't know. And you're just kind of retaking this just to really firm things up. That's fantastic. So there's going to be a huge disparity in skill level. That doesn't mean a damn thing about your own worth, correct? I took an art class in college, and I'm happy to say I actually did okay, but my God, there were people in that class who had been painting since they were 2, right? So everything I'm doing is like fresh, and I'm doing it, and these people just bringing it, yeah, I did this when I was 7, here, you want to grade that? And they were getting grades for it. I'm like, that's not fair, damn it. But, that's because my skill level and my backlog of stuff I'd done was minimal. Oh well, right? So I understand there's going to be a disparity there. Okay. So in general, what I say is if I'm going too fast, slow me down. If I'm going too slow, deal with it. Here, you can be very nice to yourself when you're selecting points. So for example, if I plug a -2 in, what do I get out? Y equals -3 times -2 plus 2. Y equals 8. Right? And if I want to use that point, could I use a scale of 5? No. So let's keep going. Let's see. What about if I plug a -1 in? Yeah, -1 times -3 is 3, plus 2 is 5. What about 0? 2. What about 1? -1. Yeah, -3 times 1 is -3 plus 2 is -1. So I'm just not going to use that point. Why would I? I don't have to, right? Do you guys see what I'm saying? We just need a few points. In fact, we only need 2, but I do 3 normally at least, just to make sure everything's kind of looking good, right? Are you guys understanding? Now there will be situations where you can't just pick the best. They're all going to be freaky, and you're going to have to make your scale go by 3s or 7s or 10s or something. You're going to have to get your scale to be good. But if you don't need to, why would you? Yes? So -1, 5, 0, 2, 1, -1. Why does it look like it's okay? Does it look like it's okay?
Mm-hmm.
Yes. It looks like it's perfectly fine. Jeff, you should have more faith in yourself, man. You just did something really good. It's all right, Jeff. So it's not a bad idea to have like a straight edge or something, maybe? And my God, some of you guys need to get graph paper. If I was a student in my class, I would say, Jeff, get some freaking graph paper. Holy shit. Because I don't know if you've noticed, but I'm not the greatest creator of graphs or writer. My handwriting's not the greatest. You guys with me? So know yourself. If you're not the cleanest, neatest person, maybe get some graph paper just to keep yourself in line. Okay. So number 3. Now this is the thing I keep talking about. With my example about when I had an equation that had 18 variables in it. Anytime I'm asking for intercept, you could solve for y, couldn't you? Why would that help? How would that help if you solve for y?
Gives you a slope.
Say again?
Gives you a slope.
Do I need the slope?
No.
Nope. Guys, gives you the y-intercept, right? M is slope, B is the y-intercept. But I also want the x-intercept. That doesn't do shit for you. So what's the quick way, given any equation, to find some letters intercept? You make all the other letters 0. Why does that make sense? If I'm going to hit the y-axis, what must x be at this point on the y-axis? If I'm on the y-axis, what must x be? 0. Because if x is 1, I'm not on the y. If x is -1, I'm not on the y-axis. So to get the y-intercept, you make x 0. To get the x-intercept, you make y 0. It's crazy. So watch this. This is going to be nice. To get the x-intercept, set y equal to 0. What does that do? 4 times 0 is
0.
Holy shit. So then how do you solve that for x? Divide by 3. So I get -4, 0. The x-intercept is a point. When y is 0, bam, x is -4, bam. So how do I find the y-intercept?
Plug in 0.
Set x equal to 0. So how do I, coming in here, yeah. How do I solve that equation? 4y equals -12. Yeah, divide by 4, I get -3. So when x is 0, I get -3 for y. And now I can just plot those. -4, 0. And 0, -3. See how I do. Not too bad. Wow. Not too bad. And maybe. Is all this coming back to you? A little bit? Okay. Now, look at number 4. That might freak you out a little bit. I don't know. I'm sorry. All the other equations on this page, do they, like, right in this equation, can y be absolutely anything it wants to be if I tell you what x is? If they give you what x is, can y be anything it wants to be? No, it's constrained, right? Y is in the equation, therefore its value must make the equation work. It can't be anything it wants to be, it depends on x, right? If a variable is missing from the equation, it could be anything it wants to be. So this equation, what variable is missing?
Y.
So y could be any damn thing it wants to be, but x must be frickin' negative 2, yeah, x has no option. So can x be negative 3?
No.
Can x be negative 1? No. So I can't move left or right. Is that cool? If I move left or right, what value changes, x or y?
X.
X changes. X can't change, can it? So what's the only direction I can move?
Up and down.
Up and down. And why is that okay? Does this have any restriction on what y can do? Y can do whatever the hell it wants to. Nah. So x equals, it's a vertical line. So where does x equal to negative 2? Well, it's right there. Where else is x equal to negative 2? Right there. Where else is x equal to negative 2? Right there. Is that cool? So what would y equal 7 look like?
A horizontal line.
Horizontal. Is that cool? Okay. One thing I wanted to say up here real quick. Shoot. What's the equation in negative 3? I kind of covered the equation a little bit. What's the idea of slope in words? Rise over run. So if I start here, how do I get to there? I rise
3.
1, 2, 3, but I have to go
Left.
back 1. So it'd be up 3, back 1. 3 over negative 1. And of course, looking at the equation, you can see a negative 3 sitting right there, right? So the reason, now real quick, why does it make sense that 2 is the y-intercept, just looking at the equation? Because how do you find the y-intercept? You make x0. So whatever number is sitting there when I'm solved for y, whatever number is sitting there is the y part of the y-intercept. It's got to be, because when I make x0, I'm left with that freaking number, right? So this is the mx plus b stuff. But why does it make sense that the number in front of the x is the slope? Because when x is 0, y is 2. If I take one step in the x direction, what does my y do? Negative 3 times that. So for every step in the x direction, I go 3 steps down in the y direction. That's exactly slope. So the number sitting in front of the x is the multiplier of what x is doing, which tells me y is doing that much as x moves. So that's the slope. Slope is how much y changes as x changes. You guys with me at all? I want you to know why this equation, which everybody I'm certain knows, why the hell that's the slope and that's the y-intercept? We didn't just go, let's make it that way. No, it's what it is. It's just what it is. Does anyone know the other equation of a line? I'll get it started.
M times.
Yeah, cool. And look at why this makes sense. What is the slope? It's when x changes by so much, y changes. So the change in y is the slope times the change in x. It's all that says. And that's really what the slope means. Okay. So coming back to number 5, how do you find the slope when they give me a line already drawn? Well, that's beautiful, right? There's no algebraic work to do. I just have to count. So pick any point you want to. That one. How do you get to the next point?
Up 3.
1, 2, 3.
Right 2.
Over 2. 3 halves. So I went up 3. 1, 2, 3 up. Right 2. So it's 3 over 2 because it didn't go back or down. What if I would have started at this point instead? I don't want to start. How do you go from this point to that point? I have to go
Down 3.
down 3. And then
Left 2.
back 2. You see how I get the same answer, right? Because the negatives cancel. So it doesn't matter which way you go, shit. So I always consider the slope to be, how do I get back to the trail if I go off the trail? Right, if I go 3 off the trail this way, I go 2 that way, and now I'm back on the trail. Does that make sense? Okay. Maybe. By the way, this is what letter in this equation for a line?
M.
M. What's B here?
0, -2.
Yeah, right? B would be -2. The y-intercept is 0, -2, 11. So B is the y value of that. So what's the equation of this line? 3 halves. So mx plus b. You guys with me? Maybe? No? Once I figure out the slope and I have the y-intercept, that kicks so much ass. I just have to throw them in and I have the equation for the whole line. Let's check this. What point is this?
2, 1.
2, 1. So what's that mean? When I throw a 2 in, I better get a 1 out, correct? When I throw a 2 in here, 3 halves times 2, the 2's cancel, I get 3. 3 minus 2 is 1. I do get that point when I plug it in. Yes, maybe? 11. I look at some of you guys, you look at me like, you start making sense, but hopefully this is all right. Okay. And then this guy is just an application. What's the formula directly for the slope? y2, y1 over x2 minus x1. Because the slope is rise. This is really awesome because it rhymes a little bit. So if I rise, which variable changes? The y's. If I fall, it's just a negative rise, correct? We used that just a minute ago. So rise rhymes with y's. You can't beat that shit. Rise over run. Y's over the other one. Y's over x's. Is that hard? Not hard to remember? What do the little subscripts mean? Why are the stupid little subscripts in there?
Just to keep track of.
Keep track. If I do -7 minus 5 on the top, I must do -1 minus 3, -3 on the bottom. Or else I'm going to get the wrong sign on my answer. So they're just there to tell you, right?
Can you do vice versa?
Say again?
Can you do vice versa with the first ones?
I'm sorry.
Can you do like y1 minus y2?
You totally could. It's arbitrary. Which point is the second point? Do you think it's -1, -7? No, because I gave the second point first. Nah, no, it doesn't matter. Whatever I call the second point, whatever I call the first point, I just have to do that. So let's do it both ways. So if I assume this is the second point, this is the first point, it would be the y piece in the second minus the y piece in the first over the x piece in the second minus the x piece in the first, right? So that would be -12 over 2. Is that cool? -6. What if I do this way? 5 minus -7 over -3 minus -1. Now I get 12. Is that cool? Over -2, which is still -6. Yeah. Is that all right? It really just relates to up and over or down and back, right? Of course they're going to come out to be the same number. They have to. Maybe. Okay. So let me do the next kind of level to this. Yeah, we got some. I might as well stay up here on this in the overhead. All right. Some people graciously didn't come today, so I have some scrap paper. All right. That's why they're not here. Now watch this. What if I had this? What if how do I say this? After 1 hour of travel, we are 50 miles from home. After 6 hours of travel, we are, what do you got, Jeff? Oh, let's say, 400 miles from home. Okay, so it seems like it's completely unrelated. Maybe. Let's see if you can read that. After 1 hour of travel, we are 50 miles from home. After 6 hours of travel, we are 400 miles from home. What's our average speed? So how is this related to slope? Well, do you guys see 2 points up there?
Mhm.
What are the 2 points?
150 and
Yeah,
6,
1 hour of
400.
travel, 50 miles. 6 hours of travel, 400 miles. You with me? So how to figure out the average speed? Well, the speed is the average rate of change of position. Oh, shit. What are the units on speed? How fast did you go to get here today? You don't have to self-report if you're like, so I'm
Miles
going
per
110.
hour.
I'm kind of happy nobody stopped me. Huh? Yeah, something miles per hour, correct? Even if you walk here, you're going something miles an hour, right? Miles per hour. Change in position over change in time. That's an average rate of change, but that's also a slope. That is a slope. Isn't slope always the y stuff divided by the x stuff? So what would the slope be here? Just look at these as points. What would the slope be?
5, 350.
All right, 400 minus 50, right? Right? Y2 minus y1 over?
6 minus 1.
6 minus 1. So 350 over 5 is 70. What's the units? What are the units of these? These are miles, correct? And these are
Hours.
hours. Miles per hour. So the slope of a position graph is the velocity, right? So slope means average rate of change. So if I have position and time, slope means velocity, speed, right? Yes, kind of. I don't know if this is not a revelation at all to anyone, but people kind of get this confused. The beautiful thing is, what are the units on your answer? It's just the units of the stuff on the top over the units on the stuff on the bottom. I mean, that's so, oh my God, that's so beautiful. So what if I had a graph of words typed, Jeff, words typed, and these are minutes. So I have 1, 2, 3, what do you got, Jeff? 80, 160, 240, right? So I have blank, blank, blank. What's the slope of that? What point is this?
24.
3, 240. What point is this?
2, 160.
2, 160. So the slope would be 240 minus 160 over 3 minus 2. So it's 80 watts. Words per minute. 80 words per minute. Or is that cool? So something we always forget is MPH means miles per hour is a ratio, right? Words per minute, WPM is a ratio. Okay, maybe. So depending on the graph I'm given, when I find the slope, I'm finding the average rate of change of this per this, because that's what slope tells me. How much did this change as this changed, right? Okay. Yeah, let's do one more thing. Let me get an example. Yeah, okay, what about this? One last example. Let's say you call the psychic hotline to get the questions on the next test, right? Well, and answers maybe, questions and answers on the next test. Right? I don't know, do they still have psychic hotlines? I have no idea. I'm sure they probably do. Right? If somebody believes in it, you can make money off of them. You call the psychic on, but no offense if you do believe in psychic, if you are a psychic, I would love some consultation. You call the second hotline to get questions on the next test. If it costs $5.50 just to call and $4 per minute, can you create a linear function representing the cost for X minutes?
Mhm.
So just so you know what this means, let me see, is it upside down? No, it's not upside down. That was a joke against myself. You call the psychic hotline to get questions on the next test. It costs $5.50 just to call. You make the call, bam, $5.50. And then it's $4 per minute afterwards. So the person's probably saying, let me consult the car, whatever. $4 per minute. Create a linear function representing cost for X minutes, okay? So a linear function just means, if I have y equals mx plus b, how do I make it a function? I replace y with f of x. That's all that means, right? Linear equation, y equals mx plus b. Linear function, f of x equals mx plus b. Ooh. Well, when you see those things, I want you to know that's all they mean, right? So, what two things do I need to get the equation of a line?
And then B.
Yeah, so I need the slope, and I need a point. Or, preferably, the y-intercept. So do I have the y-intercept? What the hell would that even mean? So, how much, if I've talked to them for 0 minutes, it costs $5.50, exactly. Isn't that the y-intercept? I like it. And then how do I get the slope? Do I have to do work to get the slope?
No,
No.
you have your part.
Why do I know the slope already?
Because it gave you a
It's
fraction
freaking $4
per.
minute. And my y-axis is cost in dollars, and my x-axis is time in minutes. So they just told me the slope. Do you guys see that?
Mhm.
Slope is 4. So what's the function?
4x plus 550.
Yeah, f of x is 4x plus 550. So therefore, if you wanted to talk to the person for 11 minutes, you can figure out how much money it would cost you and so forth, right? Or if they have a certain cost that they want to get from somebody, they can actually put, if they wanted to make $30 from somebody, they would put 30 here and solve for x to see how much time they want to keep them on the phone. Wait, the spirits are telling me, wait a minute, I'm losing the, they can just keep somebody on the phone for a while. Okay. Again, I'm sorry if you're really big into psychic stuff. All right, I think that's enough. So we basically just did 4-1 and 4-2 to a certain degree. So next time we'll focus on some example problems from chapter 4. All right.
Thank you, Professor.
Thank you.